Welcome to the first session of JupyterCon 2023. We have a bunch of different talks about a few different pieces of the Jupyter ecosystem, and I don't want to spend too much of his time talking myself. So what I'll just do is introduce Jeremy Tuloup, who's going to be talking about JupyterLite. And I'll also note just a bit of operation stuff. So I have two floating mics here. Each of these talks is going to be around 20 to 25 minutes, and we'll have about 5 minutes for questions after each one. If anybody has questions, I'd ask that you just come down the stairs to the front, and we have these two floating mics that we can give you to ask questions. Also, for any speakers that are going to be up here, including Jeremy, try to repeat the questions when people ask, because the session is going to be recorded, and these microphones are not recorded as well. So with that, I'm going to give it to Jeremy. Thanks, everybody, for coming.
Yeah, thank you, everybody, for coming. So today we're going to see how we can create interactive Jupyter websites using a tool called JupyterLite. So quick word about me. I'm a technical director at Quickstart. I've been there for 4 years already, and also been contributing to Project Jupyter for 5 years, mostly focused on Jupyter Lab, Jupyter Notebook, Voila Dashboard, and also JupyterLite. But at Quickstart, we also work on package management and also on the Mamba and the CondaForge ecosystem. So you might be wondering, what is JupyterLite? So JupyterLite is a Jupyter Lab distribution that runs entirely in a web browser, backed by in-browser language kernels. So what that means is, so if you take a normal Jupyter, and by normal I mean the thing you've been used to for many years, you have like different boxes that could potentially be running on different machines. So you have a browser for the user, you have a Jupyter server running somewhere, you have a kernel potentially running somewhere else, and you also have notebook files potentially somewhere else as well. With JupyterLite, you take all of this and you put it in a browser. So even the kernel runs in a browser. There is no real Jupyter server. It's something called the JupyterLite server, which mimics a normal Jupyter server. And by default, the files are stored in the browser as well. So what you get is something lightweight. So it's a lightweight Jupyter frontend running in a browser. You don't have to handle a Python server. There is no command line involved, at least for the users. There is no need to install Python or other packages on the user machine. And you can host the whole thing just as a static website. When you have a URL available with a JupyterLite website, you can just go to it, and it boots in seconds. So that's quite useful. And all of this is powered by the JupyterLite CLI. And you can see that as a static site generator, just like Jekyll, for example, if you already used it before for your blog or your website. You install the CLI, and then you run JupyterLite build, and you get a minimal JupyterLite website. And it generates static assets, and that can be served very easily with a plain HTTP server. And you get a bunch of stuff there, a lot of JavaScript, HTML, CSS, and also config files, themes, and all of this. The fact that it's just a bunch of static files makes it very easy to deploy. So you can have it on GitHub pages, GitLab pages, read the docs, but also on other web hosts, usually more tailored for front-end development, such as Vercel and Netlify. But also you could have it on S3 if you want. And JupyterLite is nothing really special in a way. So it's more like taking everything that happened in the Jupyter ecosystem for many, many, many years and putting that together into some kind of bundle that you can run in the browser. It's built from the ground up using JupyterLab components. So JupyterLab is very extensible. You can pick plugins, you can pick extensions, and you can create something new if you would like to. JupyterLite does this. But the core is still the same. So the kernels, even if they run in a browser, they still speak the same protocol. So you have the same JupyterLab UI, and you have the same kernels, and they speak the same Jupyter protocol. And when we say that it's powered by WebAssembly, that is because most of the kernels have been compiled to WebAssembly. So the most popular kernel is the Python kernel. And the default implementation for Python is in C. And the C is a language that compiles well to WebAssembly. So there's been a lot of effort over the past years from the PyDite team and also the CPython core team to make it possible to take Python and compile it to WebAssembly. And this is what JupyterLite uses to run the kernels. But it also keeps the things you are used to working with in a normal Jupyter. You can also use Matplotlib, PyWidgets, Plotly. And when it comes to the Python kernels, there are a couple of them. There is one based on PyDite, but another one based on the XUS Python. So with this, the fact that it's static and easy to host, it means that you can just start using a JupyterLite deployment and embed it wherever you want. So if you take this snippet below using an iframe, you can just have a Python code console in your website if you would like to, which is good, but you could also embed the whole JupyterLab UI if you want. So here it's actually an iframe, and I'm clicking on things, starting a new console, all of this. This is JupyterLite embedded in this HTML presentation using an iframe. And when people started to see this, they were thinking, yeah, it would be cool to have that on our own docs or our own website as well. So NumPy.org also has a code console powered by JupyterLite and PyDite. Same for SymPy. But there is also a project called JupyterLite Sphinx that you can use to integrate this into your Sphinx documentation. And here we have an example with IPyLeaflet, which shows a notebook. So you can embed also a notebook, only a notebook, a code console, or the full JupyterLab UI. And all of this is made easy using this template. So I'm going to show you quickly what it looks like. So if you go to this repo, so for the sake of this demo, we're going to use the XUS Python template. So if you have a GitHub account, you can go here and create a repo. So it's going to create a new repo under your GitHub account. And then you can say hello, for example. And then you click on create. And it generates a new repo, but it's going to copy all of the files that were in the template. One thing you need to do here is to go to the settings pages, and it's using the GitHub Actions to deploy to GitHub pages. And I don't think we'll have time to wait for this to complete, but you will see this little job running on the CI is going to build your website and deploy it on GitHub pages. So just in a couple of minutes, you're going to have something live that you can actually use. So I'm going to leave it on the side. Maybe we'll get back to it later. But for now, we can continue. So once you have a website ready, so starting with the template, you can add content. So you can go to the, for example, notebooks folder, add a notebook, add a data set, and then if you use the CLI, you can use the build command using the contents flag and specify the path to the notebook's content. And then what you get is the notebooks you placed in the folder, so then you can have them available here. We see that on the right side there is the iris dataset, and you can actually import also, you can read the files that you have deployed from the notebooks. So JupyterLite is built on JupyterLab, and JupyterLab has a very rich extension ecosystem, and you can actually reuse most of them. Not all of them will work, but a lot of them will work out of the box. And good examples for this is a theme, for example, or even a language pack. So here, with the XUS Python demo template, there's a file called build environment, and this is where you specify the extensions you would like to include in your Jupyter website. So that's what we add here. And then if you wait for the CI to complete and deploy your website to GitHub Pages, you have the new options available from the interface. So here we switch the theme, but here we're going to switch the language to French. And you see that it's reflected in the UI. But then you might wonder, like, how do I add packages to the Python runtime? So to do some meaningful work, you need to have some Python packages or packages in general installed. And here I'm just taking the example of the Xus Python kernel, which reuses the conda-forge approach. So there is an environment.yaml file, and there you can specify the dependencies you would like to have. So we have IPyCanvas, NumPy, and Pandas. But here we have to remember that we are still in a web browser, so things are going to be quite different. So first of all, not all packages are going to be available, but many are already there. So usually with pure Python packages, they are usually referred to as no arch on conda-forge. They should work. Maybe some of them won't, but normally they should. And then you have a specific channel called mscriptandforge, which is an effort that's been ongoing for the past year to compile popular packages to WebAssembly. So once you have this, it's the same. If you use the GitHub template, you can just open PR, merge it, and it's going to trigger a new build. And once the build is complete, you can import your new packages. So here you import NumPy, and then use it. Yeah. So this is just an overview of like the basic things you can do with this, but there are plenty more use cases and also things you can configure in JupyterLite. So here we use the CLI flag, for example, to specify the contents, but you can use a configuration file instead, so it's a bit easier to manage. There are also guides to show you how to add more extensions on how to customize the storage and how to even write your own kernel if you want. So I also wanted to briefly show a new project. It's been around for just a couple of months. So some of you might have heard about Voila before, which is a tool that takes your notebooks and transforms them into a web application that you can interact with. But still using the normal, I would say, normal stack, normal Jupyter stack. And now there is a new tool called Voici, which is like Voila, but it runs entirely in the browser. So before, we were building the site with a JupyterLite build, and with Voici, you would build it with a Voici build. So nothing really crazy about this, but what that means is that if you have this notebook, which is in the demo repo, you can use it in your static website here. But then if you switch the URL and you go to Voici tree, you get something that looks like Voila. You click on the dashboard. Here it starts the kernel. So it's going to download all of the WebAssembly packages, also the static assets. And when it's ready, it's going to execute them, all of the cells in your notebook. And you get this view of your notebook as a dashboard. It's you see in the URL is .html, so you could just take the URL and send it to someone to share your results or anything you've been working on. So this repo, this is the link to this presentation. This repo is also generated from the template, and you can play with it in your browser if you would like to. So what I would encourage you to do is, this is the one we were looking at before. So you see that, yeah, now we can go back to it. It's completed, so there are two steps. There is the build and the deployed. And by default, GitHub is going to give you an environment here. And then you can click on View Deployment. And you see, okay, I don't know why it's not HTTPS, but you can do that. Yeah, and this is the your site. So just in a few minutes, you can do your own. So I encourage you to follow what we did and also try it by yourself. And yeah. And then, yes, so all of this makes it super easy to deploy a Jupyter environment and most importantly, scale it. So if you take a normal Jupyter, usually the main pain point is to manage the servers and also the resources, because you need a server somewhere, you need CPU, RAM. But with JupyterLite, since everything is just a bunch of static files, we can leverage existing hosts like GitHub Pages, which is super convenient to deploy to. And that means it scales very easily, and you can serve a lot of users like this. Of course, the trade-off is going to be that you need to send more data to your users, because everybody has to kind of download Python pretty much and run it locally in their browser. But in many use cases, this trade-off is pretty good. For example, this makes it much easier to do interactive computing in a browser for a lot of people who don't have access to servers or don't know how to install Python or can't do it because they don't have the skills or whatever. And it's also simpler for users. If you just give them a URL, they can just go there and that's it. It also works in a mobile phone. And for educational use cases, this is also super useful. So you can use that, for example, to teach Python to a group of students. Usually, they don't need like huge environments. They could just focus on the language itself, which is very appropriate for this tool. And one big advantage of all of this is that once you have an archive with just static files, you can pretty much see it as a time capsule. Since everything is based on web standards, including WebAssembly, you could potentially just go back to that a few years later, maybe 10 years later, and in theory, it should still work because standards are here to stay. But of course, there are a lot of limitations. So as we saw before, there are a few packages that are not going to work, or maybe never going to work at all. You also can't do a lot of heavy data processing or even GPU work right now. It's most likely going to crash the browser tab first. Python has been compiled to WebAssembly, but not all of Python, so there are still things that are not available, such as multiprocessing, even though it's something that could come in the not so distant future. And yeah, depending on your use case, the initial asset download can be quite big and could be quite of a limitation if you have poor internet access. So that's something to keep in mind. Fortunately, the browsers can cache some of this, so that next time you go back to the JupyterLite website, you don't need to re-download the whole thing. So what's next? Currently, JupyterLite is using JupyterLite 3 and the previous version of Notebook 7. And what is going to be happening in the coming weeks is that there will be an update to the latest versions, so JupyterLite 4 and Notebook 7, which means that you get all of the new features almost for free, and also bug fixes and all of this. There's going to be some rework of the real-time collaboration, so you can think of that as a way to, you just have a static website, and then RTC in JupyterLite works using WebRTC, and you can connect to your peers directly. So that's something we would like to continue exploring, because it could really leverage, lower the barrier of entry for a lot of people working on simple stuff using JupyterLite, and using the same real-time collaboration package that has been developed in JupyterLab and also upstreams. There is also going to be improvements to the PyDite and Forge, and also CPython to WebAssembly toolchain and packages. I think there's been a few discussions at the WebAssembly summits recently at PyCon. And when it comes to the XUS Python kernel, there are a couple of things that are it's a work in progress right now. You can install packages at runtime, and also from PyPI, and a few optimizations to make the initial page load much faster. I mean, all of these small things are always good to take because it improves the user experience in the end. So if you want to learn more, at this conference there's going to be a talk on Voila and Voici, so the thing we saw before, and also a talk on the XUS kernels in the browser, and they're going to go more into the details on how all of this works. And if you want to learn more about JupyterLite and how to deploy your own, there's the docs. You can start from the demo repo like we saw earlier. And there was also a tutorial at the PyCon and PyData Berlin 2 or 3 weeks ago, which will be available online soon. And this one is 1.5 hours long. We go more into the details and step by step, and pretty much following the docs. But if you would like to have more of a guided walkthrough, you can also check out this one. So with this, I would like to thank you all for coming, and also thank the JupyterLite contributors, but also the PyDite, the CPython core devs, the Forge movement, and also the whole Jupyter community, because I mean, in the end, it's just reusing all of this work that is already there. So, yeah, thanks.
Okay. Thanks very much, Jeremy. Does anybody have any questions? If you do, please just come down to the front, and we have 2 floating microphones in case you'd like to ask anything. If you really don't want to come down, but you do have a question, you can also just sort of flail your arms around like this, and I'll try to run up and give you the microphone. So I had a really quick question just to start off, which is I'm curious about the transition from JupyterLite workflows into a more kind of traditional server-based workflow. And I'm wondering if you've thought at all, if you have a vision around how you could make that transition as painless as possible so that it doesn't require just starting over from scratch with a new workflow.
Yeah, it's tricky. I mean, if it's something super, I would say simple, then the transition, would be, should be pretty smooth. Yeah, I wasn't sure if it was picked up in this. Okay, so the question was, if you have a workflow with JupyterLite and you would like to go back to a more traditional workflow using the Jupyter stack, how can you do it without too many complications or redoing everything from scratch? So it really depends on the kind of work you want to do with this. So if it's simple or if it works in a browser, as long as you specify the runtime environment using, for example, the environment.yaml file we saw, you can really clearly encode your environment into a file, and then you can recreate it for the regular workflows. Same goes for extensions. So extensions for JupyterLab and Lite, they use the same system. So I would say this, like going from Lite to a normal workflow should be pretty smooth like this. But then there are a couple of ideas, I think, that have been discussed recently to allow for more hybrid approach. So I think it would be worth exploring having a deployment where you have a static JupyterLite website where you can use kernels in a browser like we saw, but you could also technically connect to another kernel running somewhere else with more resources and have this kind of seamless transition between the two. So that could help, for example, prototype something quickly, or have like a small tutorial, and then you scale to something much bigger using more data. That's something that could be explored. Yeah.
Thanks. Question over here, and the next speaker, if you want to.
Thank you very much for the presentation. It looks amazing. I have a question. Is it possible to store secrets in the notebook and share it as a website with JupyterLite? So for example, I would like to connect to the database and do some dashboard. So can I do this in a secure way?
So the question was how to share secrets and being able to use them in the JupyterLite. So databases is indeed something that comes back often. People would like to connect to databases, but usually you do it over a TCP connection, and this is not going to work in a browser. So with things like object storage, like S3, you can imagine having a token that you pass and you inject on the page, and then you can read that from the front end. So I would assume that you could use this approach to have authentication, but then it's really you have to be careful on how these tokens are also managed so that they don't leak and also can be exploited from the front end, because if they are in a browser, technically any users could have access to that. Yeah.
So inject the token in the URL?
Yeah, it depends also if the JupyterLite is deployed internally. So sometimes at companies, the fact that it's internal makes things a bit simpler because they have more control on their whole environment. If it's public, like we saw, it's more complicated because it opens many more vectors of attack. But I would say at the company, maybe one thing to check would be to have like a more kind of secure environment where you can deploy all of this and you'll be more confident, for example, making the tokens available on the front end. Yeah.
I think we have time for a short question, if there's a relatively quick one.
What are a typical performance difference between a Python kernel and the WebAssembly
Oh, yeah. So
compiled?
there are benchmarks around on some repos. So I think the best place to look for it would be probably the PyDie repo. They usually benchmark the new CPython versions, and they check how much faster it is compared to the previous version, but also compared to running natively. And if I remember correctly, at some point in the past, it was 3 times slower or something like that. But it might also depend on the workload. So yeah, I think there is still a penalty of using the browser, the Python in the browser for sure.
Thanks very much.
Yep.